Today we are going to talk about the chain rule. And to start off, why do we use the chain rule? Where do we even use the chain rule? So to answer those questions, I'm going to give you a scenario. Say we've got a function 2x minus 7 raised to the power of 3. Now, what do we see about this function? This function, let's call it f of x. A function f of x is equal to that. So now, this function is a cubic function of the linear function 2x minus 7. And as well, we can have another function, say function g of x, being equal to x squared minus 9 raised to the power of 3. Like that. So now, as well for this function, what we should see is that this is a cubic function of the quadratic function x squared minus 9. So now with these functions, it's different from the module 1, whereby we simply talked about how you differentiate x to the power of n. These are what we call functions or functions. Right? So now to differentiate these, we use the chain rule. So say we want to differentiate a function y is equal to 2x plus 4 raised to the power of 3. So we want to find dy by dx for this function. So we shall say let u be equal to 2x plus 4. Right? So what we're simply doing here is that we're coming up with a substitution for the linear function such that now y is equal to u to the power of 3. And now the next move, we shall find du by dx. We shall differentiate u with respect to x. So now du by dx would be equal to, that would be equal to 2. And then as well, we shall differentiate y with respect to u to find dy by du. And we shall get 3u squared. Now, the next thing to do, we shall say dy by dx is equal to dy by du times du by dx. And then now we shall simply substitute these, because we know that our dy by du is 3u squared and our du by dx is simply 2. So now we shall make the substitution and we'll say this is equal to 3u squared times 2, which will simply give us 6u squared. But what do we know about u? U is equal to 2x plus 4. So the final answer would be 6 open bracket 2x plus 4 squared. So now this is the gradient function for this function y is equal to 2x plus 4 raised to the power of 3. So now this is what we call the chain rule, right? dy by dx is equal to dy by du times du by dx. This is what we call the chain rule. Chain rule. And of course, we are working out by substitution. We are coming up with a substitution for one of the functions, right? So in short, we can say that for a function y is equal to f of x raised to the power of n, right? We can say that dy by dx is equal to, so we differentiate, we consider f of x to be a function just x. So we differentiate, how would differentiate x to the power of n? So drop the power, multiply by your f of x, then subtract 1 from the power, and then you have to multiply by the derivative of f of x, so which is f prime x. So we shall say times f prime x. So this is how we write it in short. And this is what has happened here. So with this function, we've dropped the power 3. So to actually work it out in short, we are saying we're dropping the power 3, right, dy by dx. Change this. We're saying that dy by dx is equal to, in short, we are dropping the power 3, multiplying by our f of x, which is 2x plus 4, then subtracting 1 from the power to get a 2. Then we are multiplying this result by the derivative of the linear function 2x plus 4, which is 2. And we know that 2x plus 4 squared times 2. 3 times 2 we get a 6. 2x plus 4 squared, which is just the same as that. So in short, that's how we write it. Now we shall look at these two examples, whereby for the first one, we would like to differentiate using the substitution way. And then the second one, we would like to differentiate directly. Allow me to erase this. Okay, so for the first one, we've got y is equal to 7 over x to the power of 3 plus 3x raised to the power of 1/3. So first of all, we need to take that denominator into the numerator, which means we're going to change the sign of the power to a negative. So we shall have y being equal to 7 times x to the power of 3 plus 3x raised to the power of minus 1/3. And this is by substitution. So we shall say let u, any letter, be this cubic function, x to the power of 3 plus 3x. So let's say u is equal to x to the power of 3 plus 3x, such that y would be now equal to 7. Then we've got the u to the power of minus 1/3. Then we said we differentiate u with respect to x, then differentiate y with respect to u. So du by dx would be equal to, dropping the power 3, multiplying by x, then subtracting 1 from the power, I've got a 2, plus, then if you differentiate 3x, we simply get a 3. Then dy by du shall be equal to 7 times, dropping the power of minus 1/3, multiplying by u, then subtracting 1 from the power of minus 1/3 that is already there, you get minus 4 over 3, to the power of minus 4 over 3. And we further simplify this to get minus 7 over 3, u to the power of minus 4 over 3. And then we said the chain rule states that dy by dx is equal to dy by du times du by dx. So now the next step shall be to simply substitute. We know that our dy by du is 7, minus 7 over 3, u to the power of minus 4 over 3. And then we know that our du by dx is 3x squared plus 3. So now we shall substitute to say minus 7 over 3, u to the power of minus 4 over 3, times du by dx, which is 3x squared plus 3. And then now making a substitution for the u, since we know that u is x to the power of 3 plus 3x, we are saying that minus 7 over 3 times x to the power of 3 plus 3x raised to the power of minus 4 over 3 times 3x squared plus 3. So this is what we get. But of course we can further simplify this. Here we can factor out the 3 such that it cancels out with that 3. So let me rather write it like this. We factor out the 3 from this. We've got x squared plus 1. And you know that 3 and the 3 will cancel out. Such that the final answer would be minus 7 x squared plus 1 times x to the power of 3 plus 3x raised to the power of minus 4 over 3. So now this becomes the gradient function for the function of y is equal to 7 times x to the power of 3 plus 3x to the power of minus a third. Now I'd like to look at the second example, whereby we are now going to find the expression for dy by dx using the shorter way, or just differentiating directly. So allow me to erase this. Okay, so now what we have, we've got y is equal to cube root of x squared minus x. But what do we know? We know that for us to differentiate this, we first of all have to remove the cube root sign, which means we rewrite this as y is equal to x squared minus x raised to the power of a third. And then now differentiating directly, we are saying dy by dx is equal to dropping the power of a third, multiplying by our quadratic function x squared minus x, then subtracting 1 from the power of a third that is already there, we get minus 2 over 3, then multiplying by the derivative of the quadratic function x squared minus x, which will give us 2x. So if we differentiate x squared, we get 2x minus the derivative of x will simply give us a 1. So now we rewrite this is 1 over 3 multiplied by 2x minus 1 multiplied by x squared minus x raised to the power of minus 2 over 3. So now this becomes the gradient function for the function of y is equal to x squared minus x raised to the power of 1 over 3. So this was module 3 of the differentiation series, looking at the chain rule. And please, if you're new to my channel, don't forget to subscribe, leave a comment and share. Thank you.